name is Darcy Black, and I work for a company called Dynamysk Automation. I'd like to speak a little bit about digitalization and how it relates to industrial process automation. I have had a few conversations around digitalization, and I find that information in white pages and online can be very specific and quite technical. So in this discussion, I want to give some of my take on the potentials of digitalization and where we can benefit in the process automation landscape from a very high level. I intend to make this a series of videos, each a few minutes, and covering a simple process automation and digitalization concepts. I'll try not to get too deep into one specific technology or one specific system. Instead, I want to draw a picture of the base technology, base instrumentation leading to basic process controls, then to data flow management and data management in OT systems and how we can tie that process information into business systems to help make business decisions. Not to mention how we can improve on the use of process information to help operations control the process. I think that as we work through digitalization efforts in the OT world, we can set ourselves up for success when artificial intelligence and machine learning become more prevalent. First, let's talk about my background. I have 0 PhD, 0 doctorates, 0 master's degrees, 0 bachelor degrees, and 1 technical college diploma. 2 professional accreditations. I'm a PMP and a CET in Alberta, but I also have graduated a few other institutions. The ABB University, Triconics University, and I have a mug to prove it. Emerson, Honeywell, Rockwell, Siemens, GE, and about 35 other industry course certificates or seminars that I have a nice little certificate for. I've been consistently working for over 25 years in industrial process automation in one form or another, usually in control system design for an integrator and occasionally as an end user in process automation system design and control system management. So I've seen applications of automation technology, many implementations, and even a few unintentional misuses of the same technology. That essentially qualifies me as an expert in no one technology or platform, but gives me a very generalist look at the integration of technologies in the real world of industrial process automation applications. Now that you know who I am, let's set the stage with some definitions. Process automation. Process automation systems are the brain and nerve center of every industrial operating facility. Automation systems cater to business critical elements by controlling process dynamics, keeping process within safety and process specifications. Process automation systems come in various sizes, from small systems like drill sites, well pads, gathering facilities, food production, breweries, to large scale systems in chemical processing, refineries, nuclear power plants, etc., multiple production facilities or complexes. These control systems can come in a few flavors. DCS, which is a distributed control system, and PLC, programmable logic controllers to start with. The bottom line is that control systems are computer-based systems consisting of many electronic components. I mentioned OT. OT stands for operational technology. OT in a nutshell is hardware and software that detects or causes a change through monitoring and control of industrial equipment. IT, and here's where it gets a little sticky, IT is information technology. Computers being used to create, process, store, retrieve, and exchange all kinds of data and information. The sticky part being that IT networks and technology do not differ drastically from technologies used in OT networks. I think the biggest differences between IT and OT are the priorities when applying the technologies. For example, in IT, the top priority is security, whereas in OT, the top priority is safety. In IT, the second priority would be privacy, OT would be resilience. The third priority in IT would be reliability, and OT, reliability probably. And fourth priority for IT, probably resilience, and OT would be security. If you look at IT versus OT, in IT world, data is king. There is a focus on protecting the data. Network patches can be scheduled on a weekend. Confidentiality is priority number 1. Use of latest technology, and if a communication path is lost, some data will not be available until the path is fixed. In the OT world, process is king. The focus is on mission critical assets and control systems. Network patches cannot be scheduled until the next process shutdown. Safety and control are priorities. If it works, who cares how old it is? Many obsolete systems exist within OT. If a communication path is lost, consequences can be massive. Loss of production, plant shutdown, process upsets, etc., etc. The IT world occasionally looks at how slowly the OT world moves and wonders why OT is so slow to change. These priorities are the reasons. Safety and integrity of the OT systems are paramount. In OT systems, to help maintain the requirement of availability and integrity, we add layers of policies, procedures, and systems. Plant management of change processes, for example, or permitting practices to ensure work is understood before being done. Finally, digitalization. Digitalization is the use of digital technologies to change how a business operates, whether that's through business model changes, information flow, usage of information, or even processing of metrics. Not to be confused with digitization. Digitization is the process of converting information into a digital format. I once heard it described as digitalization is how we manage information, and digitization is a document scanner. Anyway, now that we just said that process automation is controlled by computer-based systems, hasn't the digitalization revolution already happened in process automation? Maybe a few years ago when we upgraded control systems from pneumatics to electronics, well, sort of, but we certainly have room for improvement. Process automation is largely electronic now by using CPU-based DCS, PLC, and SCADA systems. The next digitalization step, I believe, is tying the systems and information together better, making the process information more readily available to the business layers for better business decisions, building more decision-making power into controllers, refining how data is presented to operations, and streamlining easily made decisions so that operations can focus on more complex decisions. Let me give you some examples on what I mean. Next time. Let's keep you on the edge of your seat. Anyway, again, I'm Darcy Black, and I hope to get into the details next time. Thank you.